Dear student, in today's class I am going to discuss regarding the another important topic of the time response of a feedback control system is the error analysis. So once we familiar with the first order system, second order system, and what are the types of signals applied to the control system and examples on the first order, second order system. Now another important topic of the model 3. Model 3 is the error analysis. From this particular topic, you will get a one full question. So, one full question in the examination. So, the topic of the error analysis is the expression for the steady state error. Expressions, we need to derive the expression for steady state error. ESS of t, or steady state expression for the steady state error. We need to derive the expression for the steady state error. And also the error constant or error coefficient. So the error coefficient can be two types. One is the static error coefficient, so dynamic error coefficient. So the static error coefficients are the position error coefficient to static position error coefficient to velocity error coefficient to static velocity and static acceleration error coefficient. So these are the static error coefficient. So similarly dynamic error coefficient. So and also the examples of the dynamic error coefficient. So in your syllabus only the static error coefficients are very important. So and dynamic briefly discussing regarding the dynamic error coefficient. So now I'm going to discuss regarding the before deriving the expression for the steady state error. Now what is meant by the steady state error? That steady state error is defined as the difference between the steady state values of the reference input and the feedback signal. Oh, now this is the difference between the steady state value of the reference input and the feedback signal is called as a this ES is called as a this is ES. Now this is called as a BS. RS is the reference. RS is the input in S domain. CS is the output in S domain. Now B of S is the feedback signal. E of S is called the actuating signal. Now what is the B of S? Is the actuating signal. So now the difference between the desired output and the actual output is called as the steady state error. In other words, the steady state error is defined as the difference between the steady state values of the reference input and the feedback signal. Both are same. The difference between the desired output and also the actual output is the steady state error. Is another definition for the steady state error. The performance of the control system can be indicated by this particular steady state error. The steady state error indicates the performance of the any control system. The steady state error is a measure of accuracy of the control system. Depends upon the feed forward transfer functions and also the feedback transfer functions and the reference input. So this what is the depend upon? It depends upon the feed forward transfer function, feedback transfer functions, and also the R of S. So this is the error. E of S is the difference between R of S minus P of S is the error. That is the steady state error. Difference between the desired output and also the actual output is the steady state error. It gives the accuracy of the system or performance of the control system. Now what is the suppose if I input the step signal, you know that step is one of the input, standard input signal used to test the performance of the any system. Step signals changes from sudden change. The characteristics of the natural signals are the sudden shock, sudden changes, sudden and constant velocity, constant accelerations are the characteristics of the any natural signal. So the characteristic which resembles these characteristics can be used as a standard signals for the evaluating the performance of the control system. So in this particular system, you have studied regarding the step signal. So when t is equal to 0, then amplitude suddenly changing from 0 to IE. When unit step means the amplitude is 1 no. When t is greater than or equal to 0, the amplitude becomes 1 no. Now when we input the standard step input for the given system, then what will be the response? The response of the system, C of t. C of s is the response in a C of s is called as a response of the system in S domain. S domain. I want to calculate C of t. C of t is called as time response. So the time response of a control system, the time response of a control system is a output of the it is a output of the closed loop system. The time response of a control system is a output of the closed loop system with function of the time. Output of the closed loop system. It is a function of C of t is output of closed loop system. It is a function of time. Now this C of t can be calculated by using the differential equation governing the system. Once we know the differential equation governing the system, we can calculate. Once we know the differential equation governing the system, take the Laplace transform and identify the output variable, input variables, take the ratio output to the input. Now C of s divided by output. If I know the differential equation, and then take the Laplace transform, identify the output variable, input variable, then equate the rest. So that C of s divided by R of s is equal to what is the C of s divided by R of s called as a closed loop transfer function. C of s divided by R of s is called as a closed loop transfer function of the system. Now this is the step signal. So here, what is the transfer function? If I know the GS, so HS. So now C of s R of s is equal to GS divided by 1 plus GS into HS. Now this is the transfer function. GS divided by 1 plus closed loop transfer function is equal to GS into 1 plus GS into HS is called as a closed loop transfer function. GS is called as a feed forward transfer function. HS is called as a feedback transfer function. Feedback transfer function. So, and also GS into the product of GS into HS is called as a open loop transfer function. So, therefore, if I know the closed loop transfer function, now this GS divided by 1 plus GS into HS. Now this is the closed loop transfer function is equal to what is the CS divided by R? CS divided by R of S is equal to GS divided by 1 plus GS into HS. GS into HS. Once we know the GS into this closed loop transfer function, the output in CS is equal to what? CS is equal to RS into GS divided by 1 plus GS into HS. Now, if I take the inverse Laplace transform, then we will get the C of t. The C of t is called as the output of the closed loop system is a function of the time. The C of t can be obtained by writing the differential equation governing the system and take the Laplace transform, equate the ratio, then C of s is you will get the C of s. So is equal to input into the transfer function, then the C of s value. Now, if I want to C of t, if I take the inverse Laplace transform of the output of the closed loop system is called as a time response of a system. Now, C of t is called as a time response. So, why I'm stressing this means here the C of t contains two parts. If I input the step signal, the output is the shape of the output is now this is the input. Now this is the input. Now this is the shape of the input. I expect same output. Output is same as the input, but the output is not same. It is similar to the. It is initially it is going exponentially increasing, and after reaching a certain time Ts, so it becomes constant. Now this is called as a CSS of t. Now this is called as a CT of T. Total this is called as a, this part is called as a CT of T, transient time response. CSS of T means, now this is called as a, but has two part of the output of the output of the system. Now this is the diagram. Now this is the diagram. Now input is output, we should expect a ideal output of, but we can't expect the ideal output. We expect this is the shape of the output signal. This is the input, but this is the output. You can't expect the ideal output. Now this part is called as a CT of T. Now CT of T. Now this part is called as a CSS of T. Now this entire, this signal is called as a C of T. C of T is equal to CT of T plus CSS of T. We should remember. Time response of a system means a consists of the two part or transient response and also the steady state response. So steady state response. So now this is the C of T consists of the two part. First one is the transient response and the steady state response. When I apply this step input for this particular closed loop system, so the output of this system, the output of the closed loop system is the, now we expect this is the ideal output. Output is same as the input irbekaito, but barta illa. This is not a same as the original. This is the one. Now this is the amplitude not value. This is 0.98 something. 98% only expect. Now the difference between the desired output, which this is the actual output. The difference between desired output and the actual output. Output is same as the input. We expected the output is similar to the input, but now this is the shape of the output. Therefore, the difference between after reaching the TS, so after reaching the time required to reach the steady state value, now is called as a TS value. The time required to reach the steady state value is called as until get the steady state constant output, and then fixed value, that this duration is called as the settling time. So after reaching the TS, so this becomes performance become constant. So this is actually desired output of the system. The difference between desired output and the actual output is called as the steady state error of the system. These things very important for the examination point of view, and also the future study. We go first to the future year study. So the analysis of the any system is very important. That is what I am stressing. So here the input is this. So this until reaching the CT of T, the response may be, it is the exponential version. That is also CT of T means what? Is also part of the C of T. Is not a desired response. So now when it is a response of the system. When it is the response of the transient response is the response of the system when the input changes from one state to, when the input changes from one state to another state. Input changes from one state to another state. Now this is changing from one state to another state. The CFT is a response of the, is also part of the time response. So it is the response of the system when the input changes from one state to another state. This can also be defined as the part of the time response. Is all part of the decay to zero. This part becomes zero when time tends to infinity. When the time increases, this part becomes zero. See, when the time after reaching the settling time, this transient response vanishes from the output. And also similarly, steady state response is the response of the system. It's also part of the CFT. The response of the system when the T approaches infinity. When the T approaches infinity, it is part of the response. which remains constant after complete transient responses vanishes from the output. After complete vanishes from the output, the transient response vanishes from the output. The steady state response is only the response. So it is a steady state response is a part of the time response which remains after complete time response. Complete transient responses vanishes from the system output. Now, these things are very important. You want to go through the prescribed book for understanding, for better understanding of the concept. You are better to go through the prescribed book. Now, I'm going to another topic of this error analysis. We need to derive the expression for a steady state error. We need to, what is the expressions of the steady state error that is usually asking in the examination. Derive the expression for the steady state error that I am going to discuss now. I want to derive the expression for the steady state error. I want to derive the expression for the steady state error ESS of t. I want to derive ESS of t. I want to derive. For that, I need to consider the negative non-unity feedback system. Now here HS value is equal to non-unity other than one value. Now GS value is called as a feedback transfer function. This is called as a feed forward transfer function. BS is called as a feedback. Now this is called as a ES actuating signal or error signal. Now feedback signal and actuating signal. This is called as a feedback signal. Is a RFS is the input in S domain. This is the output in CFS is the output in S domain. I want to derive the expression for the ESS of t. Consider the non-unity feedback control system, closed loop control system. The block diagram is as shown figure. Now we know that now what is the closed loop transfer function? We know that now what is the closed loop transfer function? Closed loop transfer function is equal to the ratio of output of the closed loop system divided by the input of the system. C of S divided by R of S is equal to, we already know that this is equal to negative as a negative non-unity feedback system. If it is negative, GS divided by 1 plus GS into HS. This we should remember. This is a standard expression. No, closed loop transfer function is equal to now this is the expression. So now what is the expression? Now what is the next? Now this is the standard expression, closed loop transfer function. No. Now I want to find the output in S domain. Now what is the output in S domain is called as a C of S is called the output in S domain. Response in S domain. Therefore, C of S is equal to R of S into G of S divided by, now this is equal to 1 plus GS into HS. Now this is the output in S domain. Now what is the feedback signal? Now what is B of S is called as a feedback signal. Now the feedback signal BS is equal to the feedback signal. The feedback signal FP means the feedback signal. B of S means what? B of S. Now this is the B of S is the output of this particular block. Input is C of S. The input is C of S into transfer function is the C of S. Input is C of S. Input of the block is C of S and output is the B of S. So output is equal to input into transfer function. Into transfer function is H of S. Now what is the value of C of S? So now B of S is equal to, now what is the value of B of S? Now how to find out the B of S? Feedback signal. The feedback signal B of S. B of S equals, what is the feedback signal B of S? The feedback signal B of S is equal to C of S, so into H of S, so into H of S value. The C of S into B of S is equal to H of S value. Now, what is the C of S value? The C of S value is R of S into G of S divided by 1 plus GS into HS into HS. Now this is the expression. Now what is the value of this? Now value is R of S into G of S by 1 plus GS into HS into this HS. C of value is this value and HS as it is. Now this is the feedback signal. Now feedback signal. Now error signal E of S or actuating signal. The actuating C of S is called as the actuating signal or error signal. Signal C of S, E of S is equal to, what is E of S? What is E of S? E of S is equal to, what is E of S is equal to the difference between R of S minus P of S. We know that both R of S minus P of S. Now what is the B of S here? E of S now is equal to what? E of S is equal to R of S as it is. So minus, so B of S value is R of S, G of S into H of S divided by 1 plus GS into HS. Now this is the E of S. So if I simplify this, that expression, now what is the E of S? If I take the LCM, on right hand side, now what is the LCM? 1 plus GS into HS, then R of S into this whole term. Now this is the LCM. Now here there is a 1, 1 into this, so therefore RS into this term 1 plus GS into HS. RS into RFS into this minus the remaining term is minus this term is R of S GS into HS. Now this is the R of S into 1 plus, now multiply. Now if I multiply R of S into 1, no, R of S, so plus R of S into plus here GSO, RSO, GSO into HSO minus RSO, GSO, HSO. Now divided by 1 plus GS into HS. Now RS, GSO, this value gets cancelled. The remaining term is the ES is equal to what? ES is equal to, what is the value of ES? R of S by 1 plus GS into HS. Now ES value is, now this is the value. ES value is equal to, ES value is equal to, this is the value. The remaining term is RS here. Oh, this R of S is there. Here there is a R of S. So this term, this can cancel. Oh, therefore denominator, numerator R of S. So numerator R of S, denominator. This is the expression for actuating signal. Actuating signal. Oh, the steady state error. I want to calculate the steady state error. Now I want to calculate steady state error by applying the, now this is the ES value. ES value is equal to what? ES is equal to, ES value is equal to R of S divided by 1 plus GS into HS. Now this is the way of calculating the E of S value. E of S value. E of S value. Now the steady state error. The steady state error ESS of T can be obtained by the steady state error. The steady state error ESS of T can be obtained by applying the final value theorem. The steady state error ESS of T can be obtained by the ESS of T can be obtained by ESS of T. Steady state of error can be obtained by applying final value theorem. Final value theorem. ESS of T is equal to ESS of T. It is steady state error. ESS of T is equal to, now ESS of T can be obtained by applying the final value theorem. Now ESS of T is equal to ESS of T is equal to limit S tends to 0 S into E of S. ESS of T is equal to limit S tends to 0. Now this is the expression. Now this is the expression. So therefore now this is equal to, what is ESS of value? Therefore the limit S tends to 0 S into, what is ESS of value? ES value is R of S divided by 1 plus GS into RS. GS into HS. 1 plus GS into HS. Now what is the steady state error? The expression, the final expression for the steady state error is ESS of T or ESS is equal to limit S tends to 0 S into GS divided by 1 plus S into R of S, not GS, S into R of S divided by 1 plus GS into HS. Now this is the standard expression for the standard steady state expression for the steady state error expression. So usually asked many times in the examination. So now we need to calculate the static error coefficient and dynamic error coefficient. Regarding those things, I'm going to explain in the next session. Thank you for listening.